So because every time I break up an NaOH, I get one of these. The concentration of the NaOH, the molar concentration of the NaOH, is also the molar concentration of the OH. That make sense? Anybody lost so far? All right. So we know the molar concentration of OH here for the solution you were using in the lab. It's 0.100 molar. All right? Okay. Why don't you stand up here in front of the class? And okay, and Jay Breezy, stand up there with her.
Come on, Misha, let's dance.
Oh, just right over there where there's space, okay? All right. All right. Over there in the space where it's kind of.
Space.
All right. Okay. So using Jay Breezy's metaphor, they're going to the dance, okay? So go ahead, guys. You're the dance. Wait a minute, y'all look like you're not together there. You look like you're apart.
We're not partners.
Well, now, you won't be partners when we're done, but right now you're partners, okay? All right?
I'll get her some juice. How about that?
Listen, I'm trying to help you. I'm trying to help you, but you're not helping yourselves. I want y'all together, right? Act like
juice.
Act like you're together.
Drink that juice.
Act like you're together.
Yes.
We are together.
That doesn't look like it to me. Is it lucky to y'all? There you go.
Oh, no.
All right. Yes. All right, now look. Hold it. Listen. Jay Breezy's the Na. He's the sodium. And Misha's the hydroxide. Okay? All right. If I have 100 of those groups, I'll have 100 Jay Breezys and 100 Mishas, right?
100 of me.
Okay? So, hold on. Listen. So let's say we're having the dance at the gym, and we got 100 couples, all right? In the gym. Okay? 100 couples in the gym. How many Mishas do we have in the gym?
One.
The concentration of Mishas is the same as the concentration of the couples. Does that make sense? Makes sense?
What do you think I need to go up there?
I don't know.
All right. Listen, it really is a quiet, please. Guys, we got a test tomorrow. Shh.
Give it a second. Oh, wait. No.
All right. So this is why the concentration of the OH is the same as the concentration of that if it's a strong base, because it does break up completely. Okay? If it doesn't break up completely, the concentration of OH would be something less than that, because it doesn't break up completely. Okay? But we know it's that number because it does break up completely, because that's what strong acids and bases do. All right. So then we know the OH concentration is that. Now we can find the H concentration, the hydrogen ion concentration.
All right.
All right, we just plug it into our equation. We know that we have 0.100 molar OH. Okay? And we know if we multiply that times whatever the molar concentration of the hydrogen ion is, that the result of those two numbers will give me the Kw, which is 1.0 times 10 to the negative 14 molar squared. Okay? Well, now I just have to isolate my unknown. Okay? There's the unknown. How do I isolate the unknown? Divide both sides by this number right here. 0.100 molar OH. That goes away. Divide this side by 0.100 molar. Yeah, we'll leave off the OH, but okay, molar. Okay, and this is actually molar H plus times molar OH, so they'll actually cancel out those OHs.
You're right.
So now we can find the concentration of H plus, and what is that? That's where you use your calculator, folks.
Let me do it.
This number divided by that number.
Holy cow.
How do you do the 10 to the negative 14?
I use the E button.
Oh, God.
I use the E button.
So, 1.0
1
times
divided by
negative
-13.
Okay. Where's my calculator?
Oh, God.
Oh, there it is.
I got 1 times 10.
10 to the -13.
How many significant digits do we need?
Divided by 0.1.
How many significant digits do I need?
1, 2, 3.
Wait, what did you get, JB?
2.
I got
What?
1.0 times 10 to the negative 13 molar. That's the concentration of the hydrogen ion.
I got negative 12.
What was the actual question say? Will it say find the hydrogen ion?
Sure. Might say find the molar concentration of the hydrogen ion.
0, 0, 0, 0, 0.
Quiet, please. Let's not count 12 zeros, okay? Just don't worry about it. It's that number.
1 point.
That's you got 12.
Okay.
That's what I got.
Now,
Mr. Ted, you might have done your math wrong.
I got 7 zeros. No, it's 1 point.
I got negative. Oh, I got the negative.
if you do the math right, you should get 1.0 times 10 to the negative 13.
Okay, so you're going to after we do find the...
Well, let's find these other two things over here then.
Yeah, let's do
Oh,
that.
pH and pOH.
I got
What's the-
1.0.
What's the pH going to be?
Hey,
What's the pH going to be?
pH is the negative log of that.
Yep.
hydrogen
Yep.
How do you do negative log?
oh, God.
Can you do
Negative.
that on this?
So,
Yes, you can. And look,
on negative.
folks, pay attention.
Okay.
Brian, be quiet.
Sir.
Depends on your calculator. Every calculator is a little bit different. I shouldn't say every calculator is a little bit different, but there are about 3 different ways of using your calculators to find these things you're looking for, okay?
What's going on?
All right.
Earthquake's looking to
So then we put negative log of...
Some calculators allow you to put it in just the way you read it. Mine does. Mine allows you to go negative. Here's my negative button, right? So change of sign button. Your change of sign button may say +/negative. Okay? So I'm going to say negative log of, I'm going to put it in parentheses, 1.0. And I'm going to use that second E button to do my exponent. Negative 13. No, you don't have to do times E. That would be wrong. Okay? And enter, and I get 13.
Bam.
Now, some calculators require that you sort of back into the calculation. That is to say, you put in 13. Well, I would put in 10 to the negative 13. Okay? Or 1 times 10 to the negative 13, and then hit log, and then hit change of sign. So you have to go, come out and do it backwards, so to speak.
So the pH 13 or negative?
pH 13. There's no negative on there.
Yep, you're right.
Okay?
I got
Between
negative 13. I got.
Then you didn't change your sign.
Alright, hold up.
And then the
Log.
pOH is
Negative log.
1.
Oh, that's my
The
problem.
pOH
Okay,
is
so-
1.
Negative.
Okay, what?
pOH is 1.
Very good.
0,
What is a logarithm? How would we answer that? It's on the practice test.
negative.
Okay, what is a logarithm? A logarithm is an exponent on a base of 10.
That's it.
Or a negative exponent on a base of 10.
Can you say that again?
Well, a logarithm is an exponent on a base of 10. So look, 13 comes from this exponent right there.
It's an exponent on the base of.
A logarithm is an exponent on a base of 10.
Or
Here's the base, there's the logarithm right there.
So they can't be on anything else than 10s?
Well, LOG logarithms cannot, that's true. Now, if you look down here,
What kind of other logs?
listen,
log natural.
please, I will be glad to answer the question. I was trying to answer the question before you interrupted me. There are many different logarithms. There are as many logarithms as there are numbers. But there are only 2 common logarithms. The 2 common logarithms are the base 10, which is what this button is, and the natural number logarithm, which is what this ln is.
Where is that on?
Well, you may not have it.
Your log. It's just
We
log.
will not, Brian,
Oh, found it.
Brian,
What is
we
that?
may not be, we'll never use natural logarithm in this class. In higher levels of chemistry, you do use it, but not in, probably not at all in high school chemistry.
Beyond the scope.
Yeah. Okay?
So we had HClO3. We break that into Cl and OH, or HCl and then what is it?
HClO3, that's also a strong acid. So a strong acid, like HClO3, if I put it, and I think this is a solid in pure form.
Yeah, it is.
All right, if we break it up, you're going to get H plus aqueous and chlorate ions. And it breaks up completely because it's a strong acid. Okay?
And then we just have to find.
And you have to do all that calculation too.
What is that called? What is that acid called?
What is what called?
That acid. Hydrogen chloride.
No, the acid is,
Trichloride hydrate.
I'm not going to compete to be heard. I refuse.
Turn down.
Acids are named by naming it like an ionic compound first. You name, this is hydrogen, it's on the periodic table like that. You name the polyatomic ion the way it appears on the common ions list. So naming it like an ionic compound, it's hydrogen chlorate. That's how it would be named if it were an ionic compound, but it's more than an ionic compound, it's an acid. So when we have an acid with a polyatomic ion, we drop the hydrogen name off the front entirely, and we change the ate ending to ic. So hydrogen chlorate becomes chloric acid.
I have a question.
Yes.
When you say like list the properties of an acid, do you just want like simple stuff like this list?
It's in your handout. The unit handout tells you the properties of an acid. Okay, and most of it you probably already know. Taste acidic, taste sour kind of, right? It neutralizes bases, the kind of things that you probably know, most of them. Most of it's review, yeah.
Number 11, it asks a bunch of questions about pH and pOH. Will that be all in one question, or will that be a bunch of different questions?
I don't know.
You don't know?
No?
Oh, no.
Well, actually, honestly, I do not know at the moment because I'd have to go back and look at my test.
Okay.
But the second thing is that even if I knew, I wouldn't tell you right now because it's a practice test. Not,
Oh,
I don't give you
God.
answers for the test.
Snap, crackle, pop.
Hey, Damien.
All right.
I
Okay, look, listen. Let's do one more practice problem on the pH, pOH stuff. Then I'm going to let you spend the class period working on the practice test.
Oh, score 1 for me.
So this is like the most math we'll be doing for this test, right?
Well, you have to do the stoichiometry, which we did for the lab, right? Which, by the way, that's homework. You need to turn that in. Okay? But I'll take that up in a minute, okay? Right now, let's do another calculation repeat. Yeah, those two things are all you have to do for this unit as far as math.
So we have to go out the titration stuff and all that?
Yes.
So can you do one of those two?
Sure. Okay. Well, let's see. I tell you what, if you want me to do both of those, let's make this one big problem. Okay? No? No, but it gives me a chance to do all the math at one time.
Let's just do it beyond the test.
Are we going to be using hydrochloric acid?
I want to do it as one big problem.
Yeah.
So pay
Are
attention.
we going to do the
Can we take a vote?
Just listen. Just listen. Follow along, and I'll answer all those questions as one big problem. Okay?
Hey, Billy.
I think I had some acid on my fingers. I do. Should I write this one down?
I would suggest you write it down, yes.
Those are how much you want to test. Yeah.
I want to be successful.
Well, that's a good thing.
Oh, yeah.
titrate. What is? Acid.
Concentration.
What?
Yeah, so
pH.
So if 52.75 milliliters of a 0.200 molar KOH solution is used to titrate 25 milliliters of hydroiodic acid, what is the concentration of the acid? What is the hydroxide ion concentration? What is the pH and pOH of that acid? Okay?